Welcome to Study Loop.
Okay, so for this question, we want to show that the function f of x is equal to ax plus b is invertible, and we want to find its inverse. So to prove that it's invertible, we have to prove that it's 1 to 1, and we also have to prove that it's onto, which I'll prove later. So to prove 1 to 1, we have to show that if f of x is equal to f of y, then this implies that x is equal to y. So if we just substitute what we have into these equations, we have ax plus b, because that's f of x, and f of y is ay plus b. So subtracting the b's together, you have ax is equal to ay, dividing the a's, you have x is equal to y. So therefore, it's 1 to 1. And therefore, f of x is 1 to 1. Now to prove it's onto, it's probably easier first to find the inverse of this function. So we'll just find the inverse of, so that is f inverse. So we'll just find this function first. So to do this, you just let y as f of x. So you have y is equal to ax plus b, and you just want to solve for x. So then you subtract b. So y minus b is equal to ax. Dividing by a, you have x is equal to y divided by b over a. So how does this prove that this is a onto function? What you'll do is, in your original question, you let the new variable y be some sort of real number, and instead of putting x, you put in y minus b over a. So if you put that in f as a function of y minus b over a, that is a times y minus b over a plus b. The two a's cancel out, so that's y minus b plus b. The two b's cancel out, that gives you y. But because y is a real number, this implies that this thing, because this is equal to y, it implies that this thing is the real numbers as well. So therefore, it is onto. And its inverse, we've already just found, is just this thing right here.